Alright, in this question, we are given this equation of a curve y equals to x squared plus 5x plus b, where b is a constant. We are asked to find the values or the range for which this straight line y equals to 3x plus 2 is a tangent to the curve or does not meet the curve. Alright, in my other video for the same question, I have explained how we can solve this question using the differentiation approach. In this video, I'm going to talk about how we can solve it using the discriminant approach. Now, let's look at this expression here. Y equals to x squared plus 5x plus b. Alright, we know that the curve is going to look something like this because the coefficient of x squared is a positive number, so you know it's going to be curving upwards. Now this straight line, okay, so since this straight line y equals 3x plus 2 has a positive gradient, we know that the line is also going to look something like this. Alright, so we expect that there will be only one point where both of them will meet as long as the line is a tangent to the curve. Alright, to solve this using the discriminant approach, what we must do is first we must equate both these expressions together, the one for the curve and the one for the straight line. So what we have is x squared plus 5x plus b equals to 3x plus 2. Then we bring everything over to the left hand side, so x squared plus 2x plus b minus 2 equals to 0. And then the condition for this straight line and this curve to be touching each other at exactly one point where the line is a tangent to the curve, the condition is that you must fulfill is that b squared minus 4ac must be equals to 0. Alright, so let's substitute in the values. So in this case b is 2, so 2 squared minus 4a is 1, c is b minus 2 equals to 0. Alright, so when you solve for that, you'll get 12 minus 4b equals to 0, b is equals to 3. Alright, so for this part 1, when b is equals to 3, that is where the line is a tangent to the curve. Alright, for the line not to meet the curve, alright, the discriminant condition or using the discriminant approach, the condition you must fulfill is that b squared minus 4ac must be less than 0. Alright, so the same calculation here. Only thing what you get is 12 minus 4b must be less than 0, which will mean that b must be greater than 3. Okay, so usually we write it this way, b must be greater than 3. Now, so this is how you can solve it using the discriminant approach. Intuitively, you can also look at it this way, that b is the y-intercept. Alright, b is the y-intercept of the curve. That means if b was to become smaller, that means this whole curve is going to shift downwards. If this curve shifts downwards, what would happen is, okay, if I will draw the curve, but the straight line being exactly the way it is, but the curve shifting downwards, what you would expect to see is something like this, where the curve is intersecting the line at 2 points, correct? But if the curve moves upwards, okay, and again the line being with the same equation, what would happen is the curve and the line would drift further away from each other, correct? So intuitively we can see that when the curve moves upwards, that is when the curve and the line will not meet anymore, right? And for the curve to move upwards, the y-intercept value must keep increasing. So as long as b is greater than 3, alright, because when b is equals to 3 is where they touch, alright. So as long as b is greater than 3, the curve will start to move higher up, which means they will no longer touch each other. So the second condition where the line does not meet the curve is when b is greater than 3. Alright, so I hope in this video you have learned how to solve this question using the discriminant approach. Alright, thank you. Bye.